Today, I'm very pleased to introduce to you Donald Maffly from Huron Consulting Group. Donald has a over 25 years background in software development, including testing, including as a tester, a developer, and a manager. And today, he's here to talk to us about logic programming to generate complex and meaningful test data. So please help me welcome Donald. Thank you.
Can everybody hear me? Yeah. Thank you for coming, and thank you for the introduction. I'm from Huron Consulting. We're based in Lake Oswego. Actually, our headquarters are in Chicago. We build healthcare software in addition to providing consulting for that. Today's presentation is not rated G, meaning that there will be some technical jargon, such as SQL, databases, data warehouse, logic programming. I'll try to do my best to make it accessible to everyone. If you're really excited about this stuff, you can read the paper. It's fairly technical, and it gets deep into Prologue, and it gets into a test case to test an ETL, which is a data warehouse abstraction in depth. We don't have time for that in this presentation. I'll scratch the surface, and if you're interested, you can dive deeper. Let's see, I just wanted to thank Pat Thomason and Dave Patterson of PNSQC for reviewing this paper. They did a great job and helped help polish it and form it into something presentable. Ann Ogborn of the Prologue community, notably the SWI Prologue community. So thank you to them. Today what we'll cover, talk about the testing context and the test data generation problem. From there, I'll talk about requirements that we came up to create our perfect test data generator. We'll also talk about work that really inspired the tool that we ended up building, which is research done in the area of reverse query processing. Then we'll move on to Prologue as a platform to generate test data. And finally, we'll talk about this tool, the Smart Data Generator, we've dubbed it, and we'll walk through a quick scripting example. And then I'll go on to conclude. So at Huron Consulting, we have a system called AOS, which is a collaborative workflow system serving the healthcare community, basically with the idea of bringing in revenue into the hospitals to make them financially solvent. It has a data warehouse back-end collecting historical data. This historical data is comprised of accounts and visits, as well as patient information, as well as activities that reps who use our system, information about that. ETLs, which stand for extract, transform, and load, aggregate data into summary tables. What's important there is transform. So, in other words, it takes inputs and transforms it into an output, which we're interested in testing. That data is then used in our system to serve up metrics that are used for business intelligence purposes, so that managers can see how the business is performing, how reps are performing who use the system to bring revenue into the hospital. And I kind of went a little ahead of myself there, but we were entrusted with testing the data warehouse ETLs, which is just one small component of our system in the back-end data warehouse. Oops. So, two of the complexities that we were confronted with were in the data warehouse, we have tables that are comprised of two-way linked lists. So, and there are many of them to model chronology. So you go one way up the list, you're going into the future. You go the other way, and you're going into the past. We also have columns across tables that are semantically interdependent that we needed to capture. Now let's talk about test data in general, how we could generate it or harvest it. The first place you could always look is on production systems. Now our system is deployed in at least 30 hospitals that I know of. They have plenty of data that we could use. Some of the pros are that the data is real, it's not concocted, and we might get lucky and it will land on an unanticipated, what I call a data case, which is data that's fed in to drive a test. Some of the cons are that it contains very sensitive information. We call it PHI, or PII, personal identifiable information. Hospitals are very reluctant to let that data go off their systems. So if we're to use that data, we must go onto their systems. And we kind of have our hands tied when we're on those systems. So they're not ideal to test in like a testing lab would be, where you have total control of the system. Another con is that the data is large and unwieldy. So when the ETLs are run, for instance, it could take several minutes, and it's hard to run through an entire test suite there. Nonetheless, it's a very important part of our testing strategy because of the chance that we may touch on an unanticipated data case. Oh, excuse me again. Another way we generate test data is conventionally, we have a tool in-house that we've always used that generates import files for us and also mimics user interaction, or activities, we call them. And together, that data arrives in our system, and it's transformed, and it finally reaches the data warehouse back end. This does a very good job of resembling production data, although it's not exactly like production data necessarily. Very good at generating a breadth of data, and it exercises our system end to end. So it too is a very essential part of our testing strategy, but it has some cons. It takes a long time to generate historical data, maybe 2 hours per day. So if we wanted a year's worth of data, it would take us quite a bit of time, days or weeks, to generate a year's worth of data, depending on if we wanted to skip days or whatnot. Oftentimes we cheat. We'll just generate Thursdays and Fridays, significant days around borders and whatnot. It's not so good at generating a depth of data either. So we had needs where we needed to hit very precise data points in our data warehouse backend, and it was difficult to do so using this tool because it worked with abstractions in the front end of the system, which were very different than what you get in the back end. So on the front end, in these import files, we would have accounts, patients, visits, and whatnot. By the time it got to the data warehouse back end, it would be abstracted into things like percentages and aggregations of account balances and whatnot. So for that reason, it was very hard to stage data to test our data warehouse backend. Another thing you could do is just use direct SQL injection. This is very fast to generate data, but it's just difficult to do. And why is it difficult? It's difficult because, first of all, it took an entire application layer to get the data into the system. And if you've ever worked with SQL inserts, with big tables, sometimes it can get a little tricky because you have to specify all the columns, and it's a daunting task. We've also investigated the use of third-party data generation tools, some of which you may have heard, Redgate, DBForge, whatnot. They all kind of do the same thing, and they do some things very well, and they do some other things not so well. able to generate data very quickly, good at figuring out and populating certain column types, such as names, social security numbers, addresses. Very smart about that. What they're not so great at is generating complex data where, for instance, our two-way linked list in a table. Only one of the tools could do that, and it didn't do it in a very graceful manner. Also, wasn't able to gracefully generate interdependent data across many tables. And part of the problem we found was that these tools confine you to working within a single column to populate data or to choose the data that you want to put in a particular column. And sometimes you lose the big picture context where you want to know all the other tables that are out there that are in play. So from this, we were able to to come up with a list of requirements that we wanted for our dream tool. And here they are. And we wanted to be able to generate complex data. That means particularly data that was interrelated. We wanted to be able to do it fast. That car on the left is my dream car. It's a Tesla. It goes from 0 to 60 in about maybe 3 seconds. We don't need data in our back-end database that fast, but we certainly need it faster than 2 days or a week to get data into the system. We also wanted to be able to see the forest for the trees. So what that means is we didn't want to lose perspective. So this was part of our frustration with using these third-party data generation tools. We felt like we were losing the big picture because we'd be in the myopic context of trying to populate a single column with data without seeing what was around, the trees being other tables. Really important here, we wanted to be able to precisely target data in our back end and do it quickly. Our in-house tool using the import files weren't able to do this really precisely. And part of that is because it just had to go through so many layers of computation before it landed in the back end. So it's as if you were shooting your bow and arrow and then you had to go through a lot of crosswinds. And by the time the arrow stuck, it wouldn't stick in the original intended target, if I could give an analogy. We wanted to be able to leverage the database schema. This is what third-party generation tools do real well. But at the same time, we wanted to give hooks to be able to program application knowledge into the system. And we feel that the third-party generation tools didn't do that very well as we'd like. So this table summarizes our requirements on the left there, complex data, precise data points. Our dream tool was going to meet all those requirements. And then you can see in some of these other approaches, there's deficiencies. And we just wanted to be able to fill those gaps wherever you see a no. Our discovery process. So this is a timeline of how we went from a problem to a solution. Our solution being our test data generator. First of all, it's important to note that what we were testing was highly spec'd. So these ETLs, these data warehouse ETLs, they weren't some mysterious black box. They were tightly spec'd. Our business analysts pseudo-coded the behavior of these things. So we knew how we were to test them. And we used those specs to come up with test cases. So given a particular input, we would verify that the ETL produced an expected output. We ended up originally using our in-house data generation tool. And what we would do is we would write SQL selects after it was done generating data to identify if the data that we needed actually landed in the database. So this wasn't a test, it was a pre-test to see if the necessary condition was there before we could even run our tests. Now, what the aha moment for us is after having done this for maybe a year or two, it dawned on us that what if we could reverse these queries that are looking for very complex interrelated data, instead of querying for it and seeing if it were present, to reverse that and to generate that data that we were looking for. That would make our lives so much easier. So we didn't know such research had been done until we actually looked. And it turns out data research has been done by a guy named Karsten Binnig in 2007, reverse query processing. Now, this work was done to reverse SQL. And it turned out to be an abandoned track of research. I talked to Karsten directly. He didn't even have a working prototype. I suspect that it was too ambitious, with the task that he was trying to undertake to reverse SQL to generate data. But the important thing was that it showed us that there was a way, there was a need, that he wasn't able to fulfill it necessarily by reversing SQL. So what our company does is every couple months we have something called Autonomy Day. Our managers let us explore anything we'd like for 2 days. And at the end of those 2 days, we need to present on it. That's the only catch. So what I chose to research was this problem. Instead of trying to reverse SQL, I thought maybe Prologue would be a poor man's way of solving this problem. I suspected that, I'll get into that in a second. First of all, Prologue means programming in logic. It was a language that was born, or I don't know if that's the right word for a language. Is a language born or established or invented? That was in around 1970 by a trio of people. 2 in France, I can't pronounce their names, and then there's Robert Kowalski as well that played a role in this language. It picked up a lot of steam in the 1980s during the Japanese artificial intelligence effort. You may have read a book called The Fifth Generation by Edward Feigenbaum. So Prologue was the chosen language for that initiative, and so it picked up a lot of steam in the 80s. It lost a lot of steam, I think, as the promise of AI kind of faded in the late 80s. I guess the funding went away. Today it's still used primarily in academic circles, but there's still applications of it in expert systems, maybe in voice recognition, pattern recognition. One thing that we found interesting was that it was a lot like SQL. It's declarative like SQL. It's good at expressing relationships like SQL is. And finally, it's list-based. And so you may recall that we had a problem of having to generate two-way linked lists within tables. And so because this language was list-based, I figured it might be a good starting point or offer promise there. So before I get into data generation, I want to first take you through a problem that's very close to that and show you how Prologue solves that problem. And then we'll jump into how Prologue can solve the data generation problem. So this is a problem from when I was a 12-year-old boy, a bored 12-year-old boy. I used to love magic tricks, and I loved logic problems. So I dug this up, and this is an example of how Prologue can solve this particular problem. The problem is to distribute 8 cards. You'll see them right here. We have ace, king, queen, jack of spades, ace, king, queen, jack of hearts across these 8 squares. And the key is we want to make sure that a king lands on square 6. Also, 2 cards of the same denomination cannot border. So 2 kings cannot border, 2 aces, etc. Each ace borders a king. Each king borders a queen. Each queen borders a jack, and no queen borders an ace. So I've actually solved the problem right there for us. But if I asked you to solve it, it would take you a little bit longer, I'm sure. And why is that? Because there's about 40,000 different combinations of how those cards could be distributed across that grid. And there's only 32 different solutions to that. So think about how you would solve this problem. I think the most obvious way is you'd permute the cards across the grid, and then you'd test each combination against our criteria. So our criteria being 2 aces cannot border, 2 kings cannot border, etc. We went through those a few seconds ago. What would that look like in Prologue?
Like some water.
Oh, I have it here, yeah. Thank you. Yeah, my throat's dry. Thank you. First of all, the primary data structure here is a list of cards on the grid positions. What this connotes is we have both of our aces. Ace 1 is on the first position on the grid. Ace 2 is on the second position. The king is on the third, etc. King 1 being the king of spades. King 2, the ace of hearts. So there's our 8 cards across in our grid. Very simple data structure. So there's a Prologue list in action. Next, we're going to add some facts describing JID adjacency. So what these facts are, these are just like routines. These are not Prologue functions. These are facts that we've written in Prologue. The first one says square 1 is adjacent to square 4. Square 2 is adjacent to square 3. 6 is adjacent to 4, 5, 7, and 8. And you'll see how we use this fact in a second. Here we are using a built-in Prologue function called permutation, and we're going to take our list and we're going to permute it. And this is what comes up with our 40,320 permutations, which happens to be 8 factorial. If you go back to your combinatorics class, I think that's what that is, 8 factorial. It's been many years. Then we run each of these permutations through our criteria. So here are our criteria. This is next to, I'll show you in the next slide, but what it means is it returns true if, for instance, on that first line, an ace is next to a king. That would be ace 1, maybe the ace of hearts. A king is next to a queen, a queen is next to a jack, and then we have some is not next to's. A queen not next to an ace not next to an ace, king not next to a king, etc. This is what is next to looks like. Basically, it returns true if card 1 and card 2 are next to each other in a list, one of our permutations. You can see buried in here is our is adjacent to fact that I showed you a little earlier. And that's it. Maybe that's 20 or 30 lines of code. Now, if you did that in a procedural language, like Java or C#, it maybe takes 200 lines of code. I don't know, I haven't tried it. Maybe if you use a recursive approach, it's 100 lines of code, but it's significantly more. So when we execute it as a query, we come up with 32 solutions. You'll see here that a king lands in position number 6 every time. So that's really the answer to our question. In squares 7 and 8, a jack and an ace can alter. How could we be smarter about this? One thing we could do is bail out after we find the first solution using what's called a Prologue cut, which just says, okay, we found our first solution. We're not interested in any more solutions. Instead of going through all 40,000, then we go through maybe 1,000. It's much more efficient. Another thing we could do is don't present any permutations where a king is not on square number 6. So we know that that's important. So instead of 40,000, a search space of size 40,000, maybe we reduce it to even smaller, to 4,000 or 5,000. And this is something that we can achieve using finite domains in constraint language programming. I'll explain a little bit to you about finite domains in a second. Now we're going to make the jump to test data generation from card number 6. There's important similarities. Imagine now that the card grid is like a row of table data. The card denominations like data types. So, for instance, square 1, let's say we wanted to make sure that it were a queen. It could only be a queen. That would be a kind of like a confining a column to a data type. And finally, filtering criteria, reference column values now instead of our cards, similar to the way a SQL where clause would work. I'll show you an example of that in a second. So our data generation approach is the same as the one we followed with the cards. First, we create permutations of table row data. Now, in this case, we may have more than just one grid or more than just one table. And furthermore, that it will be related in some way. And that we can define in our data case. I'll show you that in a second. And then, like our card problem, we'll throw out the meaningless permutations by evaluating each combination against some criteria. Finite domain. So before I jump into this a little bit, one of our big discoveries when we were looking at our ETLs was that some of them looked at considered maybe 4 or 5 different tables, some with hundreds of rows on them. And what we discovered was the ETLs were blind to a lot of what the data that were in those tables. They really didn't care. They were only interested in 4 or 5 different columns on each table, maybe 15 columns in all. So what that said to us is that we could ignore the values or put sensible defaults in the ones that the ETLs didn't care about. So in this particular fictional example, we're setting finite domains on columns that we're interested in or that the ETL that we're testing is interested in. Everything else the ETL doesn't look at. We don't need to worry about populating it. Now, in this case, on table A, we're defining a finite domain on column 2 to be values 1, 5, and 9. Arbitrary example here. Column 4 would be Fred and John. Everything else we don't care about. We do something similar on table B. Before getting into a scripting example, I'll just talk to you about this smart data generator, how it's architected. It's written in Prologue. It takes an app-specific configuration, which basically defines the tables that we're interested in, also perhaps sensible column values you can define in this app config, as well as how you want the code to be generated, which happens in step 3. Step 1, it reads in this app config file. From there, it goes to the database schema, reads the schema, and then it's able to generate a Prologue API to that data. This is object relational mapping, which has been done before in other languages such as Java, C, C++. In step 4, the tester will write a program to that generated API. The SDG will read it in and then insert the data into the table, directly into the database. So, as I mentioned just a second ago, it's an object relational mapping generator, essentially. Like most object relational generators, it generates creators and constructors for rows on each table, getters and setters on each of the columns. What it does in addition to that, to most object relational generators, is it generates finite domain infrastructure. So things to help the coder define these finite domains on columns. So now I'll walk you through a quick scripting example. This one's kind of dumbed down a little bit, but it's purely for demonstration. If you want a more sophisticated one, I refer you to the appendix, which gets in depth into testing an ETL. This is a simple one. We're taking baby steps now. This is table T with columns X and Y. We're defining a domain on X to be values 1 and 2. and on Y to be A and B. Here we are calling the constructor create T, and it generates us 4 different rows with all the different combinations. That's the Cartesian product of the size of those 2 domains, so that's 2 times 2. 1A, 1B, 2A, 2B. Now we'll get a little trickier and we'll add a second table into the mix. The second table has a foreign key. This is where you'll have to have some relational database background over to the first table. So there's an additional column on table 2 called FK to T, which is basically the primary key ID over to that table. To do that, well, I won't gloss over this, but it also has columns X and Y over domains 1, 2, and AB. On the bottom line there, you'll see our added code where we create our T2. And here's the object setter, which was generated. We're setting foreign key to T on T2 to be the OID, or the primary key of T. So you can think of that as a reverse join. So if you're familiar with SQL, joins are used to relate 2 tables or show how the 2 tables are related. This is the reverse of that. When we execute this program, we'll get 16 different solutions. So think of each of these as a data set, a separate data set. Notice here that in that 4th position in T2 that's the foreign key. The foreign key over to table 1. So 1, 1, 2, 2, 3, 3. In positions 2 and 3, you'll see our data value combinations 1A, 2B, etc. Now let's get a little fancier here, and we're going to filter out unwanted permutations. So let's say that we wanted to exclude any where T1x equaled T2x. So how do we do that? Well, we just add another line here that says if this returns false, it will throw that. If this returns false, it will throw this combination out. T1 does not equal T2x. And sure enough, we lose 8 of those. You'll see in the second position is x, where x is the same, 1, 1, 1, 1, 2, 2, 2, 2. All those get thrown out. So how is this a reverse query processor? So this shows you SQL on the left and what an SCG Prologue to reverse that SQL would look like. When I say SQL, I mean a SQL select. So in SQL, we have, you typically have the column values that you're interested in, a primary table, and you're joining to a secondary table, or more, probably more tables than that. And you'll have a where clause at the end that will further constrain that data. SDG Prologue, a program would look like very similar, where you have your columns in SQL, you're defining your domains, your finite domains. You'll have a primary table, and you'll have a join to a secondary table, and then finally you'll have constraints that you want it to obey. The takeaway, SCG met all of our data generation requirements that I called out in the beginning of the presentation. Notably that we wanted speed, we wanted it to be fast, and we wanted it to be kind of SQL-like. So what I mean by that, that was the forest through the trees requirement, where we wanted to be able to see all the tables that were involved. We didn't want to get lost in how we were going to populate a single column, but we wanted to keep that big picture. SDG is not reverse SQL, but we think it is reverse query. That last slide showed you that. It's essentially an object relational mapping tool for Prologue. SDG is. We think it could also be used in contexts where you need to generate data for data-driven testing contexts, not just relational data. And that's something we'd like to explore more. It's not commercially available yet. It is patent pending. Part of this is that the company that I work for would not let me present this unless we went through a patent process. So my hope is that at the end of this year, this patent provisional process, is that we could either commercialize this tool or put it in the open source. We'll see how that goes, depending on what kind of excitement it generates. But otherwise, in the meantime, I feel that the paper has enough detail for you to roll your own. In fact, it's much easier to generate data into flat files, and from there you could pump it into a database than it is to pump it to generate directly to a database. So if you were excited about this, you could generate to flat file and then load to database using a separate tool. Future work. As I mentioned, SGG, it'd be good to explore generating into non-relational test data. I also think that data log, which is another flavor of Prologue, which has better integration with databases, may provide better caching and efficiency. So that may be worth exploring as well. And I also think SDG has other data analytics applications, primarily because it's a logic programming language. I don't have any idea what they are. I just have that feeling that there's some gold mines out there. Let's see. 1 second. Excuse. Oops.
Just about 5 minutes left.
Great. Right on time. Any questions?
You mentioned that you are doing a lot of testing at customer hospitals, doing as part of your job and functions. And are you using this tool there? And how are you getting around? And hospitals are very finicky in what you could put on their networks. How are you getting around that, their limitations?
No, we're not using this tool out in production, but we are using it to mimic what we might see out on a production system. And yeah, you're right. Hospitals are extremely finicky. That doesn't rule out us using the tool out there on these systems. The difference is that those systems have different configurations, and it very well might be interesting to use this tool out there. But again, their IT departments are very restrictive as to what we can even put on their systems. I doubt they would even allow us to put this tool out there on those systems. But yeah, if I could do that, I would do that. Anybody else?
So you mentioned that you only populate columns that you're only interested in. So wouldn't that lead to data integrity issues when you look at the data as a whole?
Good question. So that's what the middle layer does. It handles all of those, the ugliness of managing your data. So that's what most object relational management object relational mapping tools do for you. They provide you an abstraction that's safe for you to program in without breaking integrity constraints. And most of those integrity constraints are around relationships. Now, that's not to say that you may have the rope to hang yourself. I mean, whenever you're dealing with a relationship or a foreign key, you could get into trouble. But more often than not, when you're populating these columns, they are not relationships. So you don't necessarily need to worry. Well, see me afterwards because it's a complex topic. Go ahead.
It seems like it would be easy, as you're using this, to generate sort of the full breadth of the data set that conforms to your rules. That could end up being a really huge data set. Did you run into that, and then what strategies did you use to choose like a subset of data that was relevant to your task?
Well, you have control over how much data you generate.
Like have inbound parameters basically to say I want X amount.
Yeah, you can, for instance, you can choose the number of tables you want involved. You can choose the size of the domains on each of those columns. So I don't know if I answered your question, but you generally have full control over it. Now, could you repeat your question again?
I'll catch up with you.
Okay. Any more questions? Go ahead. Yeah.
How fast would it take you to generate, say, I don't know, 10 tables, 10,000 rows?
How big are the tables? Maybe 20 to 50 columns.
Yeah, go with that.
Maybe half an hour to an hour, depending on. There's a lot of. It depends on a lot of things, but one test that I ran was I just looked at the number of rows being generated. I didn't look at the number of tables. It was able to generate some of the average number of columns per table was maybe 40 or 50. It was able to generate maybe 1 million rows per hour. So if you needed, do the math on that, in 24 hours you'd get 24 million rows.
You mentioned that prior to this, it took you 2 hours to generate a day's worth of data. How fast is it now?
Well, I haven't really looked at that. It's a lot faster, I can say that. It's kind of an apples to orange in some ways because this other data generator that we had generated data for the front end of the system as well as the back end. But if you just look at the back end, in other words, the data warehouse, that would be a fair comparison. We didn't really, so let's see, if 2 hours using the old tool would generate 1 day. 2 hours using the new tool may generate, could generate maybe a year, depending on what part of the data warehouse you were focusing on. But it's a hard comparison to make. But it's a lot faster in general, I can say that. Any other questions? One more question. Okay, thank you all. I have some. If you need to contact me, contact information is right here. Please feel free to do so, and I'm available at the conference. Please approach me if you have questions.